All right, everybody, thanks for joining in today. Today we've got myself, Matt Walker, and Troy Daniels is also here with us. I'm going to be talking about why the battery management system, also known as a BMS, matters, and also understanding the difference in BMS functions between the AmpliPHI and Phi batteries. So we're going to go into a lot of details about how a BMS works and the differences in the BMS in all of our products and how to choose the right one for whatever project that you're working on right now. We're also, of course, going to have a live Q&A at the end. So if you have any questions, go ahead and type them into the question bar that's either going to be at the top or the bottom of your screen right now. And we will definitely get to everybody's questions. So just shoot them in there at any time. I'm going to go ahead and jump in now. I'm going to begin with a brief overview and history of our company. We were actually founded in 2010 as OES Energy. So ultimately, we were founded to solve an issue of unsafe and hazardous lithium chemistries, as well as really the drawbacks of lead acid batteries not being able to meet the needs of a lot of different applications. For example, mobile power packs, small mobile devices. So ultimately, we began with lithium iron phosphate chemistry right from the beginning into some really hardcore applications like military and emergency response right off the bat, just kind of proving our roots in this industry. In 2013 and 2014, we began to kind of expand our product line, always considering not only the end user, but also the installer and how their experiences with our product are going to be. In 2015, we relaunched as SimpliPhi Power, and now we are ramping up manufacturing at our Ventura County, California location. Our solutions are always at the front line of all listings and standards so that we can make sure it's able to be safely installed in your area, no matter what your jurisdiction requires. For example, we even just finished our 9540 testing on our Schneider Access cabinet. So we now have that on both the Solar Access and the Schneider Access unit. Our batteries are also 1973 UL certified. Now, UL certifications, I'm sure all of you installers are familiar with, but these are really important and increasingly so, especially in California, New York. Certain states are first to adopt different UL listings, but then the rest, of course, in time will follow. These aren't just needed where your property is going to be inspected, but also think about insurance purposes. Our batteries are definitely very versatile. They're used in a variety of applications right now. Especially the people out in the field, you're all familiar with customers complaining about the utilities finding new and more ways to charge them extra money, right? So we're all familiar with peak shaving, which is essentially just being charged extra to use a certain amount of power at any time, and time of use rates, which is being charged more for each kilowatt hour between any certain hours. Like, let's say, for example, I get charged about 30 to 40% more between between 5 p.m. and 9 p.m. And of course, if you want to use solar power at your leisure, you're going to need storage. So our batteries are used widely in a variety of applications, not limited to these three. Like I said, we use only lithium iron phosphate chemistry, and we only ever have. And we use cylindrical form factor in all of our batteries. So when we look at different form factors, cylindrical form factor is kind of like a AA battery, right? That is a cylindrical cell right there. A pouch cell, that's often used in things like laptops, and it's great for smaller needs, but When it comes to larger applications, a pouch cell can actually swell and shrink a little bit depending on temperature, as well as it's also prone to puncture and just not super durable in general. A prismatic cell is definitely very durable. It's just a bit more bulky, it involves more packaging and casing, so it doesn't allow you to pack, the biggest punch in the tightest, smallest package. Awesome. So now into today's content. What is a battery management system? So really, a way to think of a battery management system is that it's the brain of the battery, right? So you've got this lithium battery, and the BMS is kind of its protection. It serves as monitoring environmental conditions, it calculates data based on the conditions of the cell, like voltage, current, amp hours in and out of the cells. It's also going to keep the battery from being able to function outside of its, safe parameters defined by the manufacturer in the BMS. It's also going to ensure that the BMS has access to its full capacity during each cycle instead of being limited by its weakest cell. A battery management system is not technically required for any battery to, physically work and turn on and power your appliances. But all batteries really would benefit from a BMS performance wise. For example, with a lithium battery, a BMS is going to ensure, the capacity of the battery is not limited by the weakest cell. It's able to balance the cells during charging and sometimes discharging as well. It's also going to protect the battery from abuse, maybe high voltage spikes or high current spikes coming from your charger. And it's also going to prevent thermal runaway. So with lead acid batteries, which many of you are familiar with, of course, we all began with them years ago, and now we're switching over to the newest technology. With lead acid batteries, they really don't need a BMS, as they're honestly not designed to last nearly as long as lithium batteries, and maybe not quite as sensitive to damage outside their normal operating parameters. However, they definitely would benefit from one performance-wise. It's often really a cost decision to not include a BMS in the lithium in a lead acid battery. Now, wanted to show just a vague example of wiring a BMS into a battery, right? So what we've got here is an example of a 12-volt battery with a BMS wired in on the negative side. This BMS does actually have a cell temperature probe to monitor the temperature of the batteries. For example, that's needed to cut off charging when the temperature gets too low or even too high. Not all BMSs do have a temperature sensor though. So BMS is also going to be able to open and close the circuit. It's going to use FETs or contactors to open and close the circuit. It's not going to be able to throttle current or modify voltage that's coming into the battery. So I want to harp on that for a moment longer here because we get a lot of inquiries where people have said, my charge controller failed and it let the PV's voltage through to the battery. Like the battery's damaged. Why didn't your BMS solve that? And look, a BMS essentially it cannot modify the voltage or power coming into the battery at all. It can't decrease the current from 50 amps to 30 amps, and it can't increase or decrease the voltage to match what the battery wants. The only thing a BMS is designed to do is open or close the circuit. So if it sees something it doesn't like, it will open the circuit, and then once that condition is corrected, it will close the circuit. Now, there are many types of battery management systems. For example, an analog BMS. This is what's used in our Phi batteries is an analog BMS. This is programmed only during manufacturing, if at all. There's no real user interface here for you to adjust to the settings and program it to your needs. It's simply made up of hardware that's tried and true, like FETs, resistors, diodes, etc. There's no real controller on this board. Its performance and operation is based only on electrical signals, so it's not based on communications with other devices. And it relies on the values across those things like diodes, resistors, to take action, like opening or closing a switch, for example, as an action. It doesn't transmit data to any other system equipment. And it also doesn't receive any data from any other equipment. It's really a simple but tried and true method that has been used for years. Now we have a digital BMS, for example, in our AmpliPHI battery. A digital BMS usually has a user interface and communications with external devices. Often it is programmable, but it doesn't necessarily need to be programmable in the field. Sometimes it's just programmed, um, behind the scenes at a manufacturing facility. Sometimes it can be programmed in the field, depends on the BMS. So this BMS is going to take digital inputs and convert those to those same analog electrical signals for the analog devices to perform actions. It may or may not transmit data to external equipment, but oftentimes it does. Most of these batteries are communicating with charge controllers or inverters, things along these lines when they have a digital BMS. And often batteries with a digital BMS also have an analog as a failsafe. So this is, like I said, the analog is really a tried and true method. There's also low voltage and high voltage battery management systems. So we get a lot of questions about why can't I put your 24-volt batteries in series to create a 48-volt or even higher voltage battery bank? So I was even confused about this myself at some points, and really just had to draw it out to understand it. But basically, if one BMS, senses that this battery is too full, I'm going to open the circuit so it cannot charge anymore. So that opening in the circuit is going to have the full circuit voltage of, let's say it was 48 volts across that BMS. If the BMS is not designed to handle 48 volts, it will essentially cause damage right at that point where the circuit has opened. So really, that's where you run into the issue is when you have a series connection of a low voltage BMS not designed to handle the high voltage it could be exposed to. That's when they can be damaged, is when they open circuit. With a high voltage BMS, we're talking about a series connection here. So this is going to have much different hardware, a BMS that's designed to open the circuit on, 1,000 volts DC, for example. We're also going to be looking at a stack controller that's going to coordinate readings from all the modules BMSs to make decisions. So the stack controller is, in this case, more of the brain operating all of the miniature brains that are each BMS. It's a little more complex in this scenario. But again, the stack controller is what's designed to actually handle the full voltage of the stack, such as 1,000 volts. Each individual battery within the stack does not necessarily have a BMS, though. It definitely will have a cell measuring and balancing device. So this device is going to read data and report back to the to the stack controller. So why are battery management systems so important? Why are they needed? The most important thing and the kind of essential duty of a BMS is to balance cells in a lithium battery. So balancing cells at the top of each charge cycle is typical for a passively balanced BMS. So it's going to look at each cell voltage, and let's say that this cell here, cell second from the top, that's full before any of the others. So if it sees this cell is full, it's going to bleed off any excess power going to the cell through resistive dissipation. So essentially just burning it off as heat. While that's happening, all the other cells are allowed to continue charging. Now, the power dissipation here is a really small scale in most cases. We're talking like a tenth of an amp, maybe even less. I mean, maybe a half of an amp if it's a very large battery, but this is a very small scale power dissipation as opposed to active balancing, which we're going to talk about soon. Also wanted to take a moment here to just pause and describe that, BMSs have many different functions that can be customized for each battery. We're talking about low voltage protection to help you from just draining your lithium battery all the way to 0% or completely dead. We're talking about high voltage protection to prevent overcharging, overcurrent protection, under voltage, higher voltage, overcurrent. All of these things are built into almost every BMS, as well as temperature is built into most newer BMSs. When you look at, active cell balancing, this is much larger scale than passive cell balancing, right? Just another function that's built into some BMSs, not every BMS. This is going to allow one cell to actually pull power here from a full cell and then switch and push it over to an empty cell. Oh, excuse me here. So this would only occur if there was really a significant voltage difference between cells. And that sort of voltage difference is only going to occur at the very top and the bottom of a charge cycle, right? So hopefully we're all familiar with how lithium batteries have a very flat middle of their state of charge curve. So between 75 and 25% state of charge, that battery is sitting very, very steadily between 51 and 52 volts for a 48 volt system. So there's not a whole lot of voltage variation there until you get to the top of the charge cycle and you're going from 52 volts to 56 volts in just that final 75 to 100% state of charge. So that's where you'd see a voltage difference, is at the very top or the bottom of the charge cycle, which would actually allow active cell balancing to occur. Whereas passive cell balancing does not require a huge, voltage difference to occur. It normally occurs at the top of a charge cycle, realistically, but it could occur at any time during the charge cycle. So active cell balancing, this is actually a great way to utilize second life cells that have a lot of variation in their capacities remaining, whereas passive cell balancing is really all you need for most brand new batteries. The two can actually be used in conjunction. So theoretically, a battery could be made that has both active and passive cell balancing at the same time. But honestly, either of these are going to be very small scale in comparison to the actual charging rate of the battery. So, we're talking about charging a battery at like 35 amps for our 48 volt batteries. Active and passive cell balancing are both going to be under an amp. So talking about very small scale in general. Well, also just go back, and I probably should have said this earlier, but none of these things specifically apply to our batteries. For example, like the scale of the charge currents is just a general estimate to show the magnitude. 1/10 of an amp for passive, 1 amp for active. It's just a general estimate. Additionally, what battery management systems do and why they're so important, beyond even cell managing, cell balancing and protection, they can, provide additional protection with a closed loop BMS, where both the BMS and programming of external devices can work together. So, for example, in our Solarc access unit, the BMS does not modify the charge currents itself. It communicates with the Solarc inverter, which can actually, this tells the Solarc inverter what charge current to charge it at. So it's a very intelligent system because the BMS is telling the Solarc exactly how it wants to be treated. So it'll work with the inverter or charge controller and also independently as well. Whereas in analog BMS, this is going to work totally independently of other equipment, and it's mainly for preventing disasters and serious misuse, things that would cause immediate damage, but it's not designed to be the only line of protection. When you're talking about an analog BMS, this is something where you still need to program the charge controller and inverter correctly. Awesome. So I'm going to go ahead and hand over to Troy here so that he can tell you a little bit more about that programming specifically.
Awesome. Thank you, Matt. Hey, everybody. Troy Daniels here. I'm going to jump in here and kind of take over for the remainder of the presentation. Just want to give everyone a reminder, any questions, there is that Q&A section. So if you have any questions at all, go ahead and type them in there. We're going to have some time at the end here to go through. So let's talk a little bit about programming and its relationship to BMS. And give me one moment here, as it sometimes a little lag as there it goes. All right. Let me just make sure I didn't skip a slide. Perfect. So let's talk understanding programming and design. Excuse me. So internal analog BMS with the 5 batteries. This, again, we're talking about we're going to go a little deeper here into our specific products, what we have, and kind of the specifics around it. So if you are using our PHI, our standard battery, we're talking about our analog BMS, our internal analog BMS, no comms built in. When that's the case, programming external equipment is really the main source of protection when using the standard batteries, and the BMS alone does not provide warranted protection. And I think we've talked. If you took my warranty presentation recently, you get a little idea of that and kind of what I mean by that. As far as programming goes, we're talking everything from charge and discharge. We're talking about voltage set points on the charging, low battery cutout, tons of different functions that really, again, are looks like might have taken back control there by accident, Matt. That are really controlled, there we go, by your ability to program into a system. So here's the Schneider Connects SCP, for instance, is one device that you might be using to program set points. The BMS is not putting in set points, and you can't just bypass this programming. It's also really important when using the analog BMS to consider the size of the battery bank and the max continuous charge and discharge, the 2-to-1 ratio. If you've taken any of my other presentations, it's pretty rare that I get through one without mentioning this 2-to-1 ratio on our 5 batteries, meaning double the amount of kilowatt hours for kilowatt capacity of inverters. So 8 kilowatt inverter, we want 16 kilowatt hours minimal on that. With the 5 battery, that's really important. Even if you're using an inverter that maybe does have some programmability there, I know a few that are starting to pick that up as a function. It's just super important. Just follow this guideline. You'll never have any problems. But when it comes to the BMS, it doesn't have the ability to ramp down the inverter as far as the output and the discharge, which we'll talk about why that's different from our more advanced battery management system. So the AmpliPHI is our more advanced battery, and it has closed loop communications. And this can auto-populate set points. So the most crucial settings are already programmed. This is automatic. The second you hook up that battery to, currently it's with the Solar, and you select lithium battery and hit it that 00 on the battery type, it will dump all of its settings. The battery management system knows how many batteries are within the system. So if you add more batteries, it can auto populate or adjust those set points to say, hey, I've been added another battery. My adjusted capacity is this. My other settings that maybe max charge or max discharge can also change. It also does things like, the voltage set points as far as charging voltage and low battery cutouts actually identified as state of charge, because the battery management system in the AmpliPHI itself is reporting data to the system itself. It's important to kind of know that that's kind of a function here, is that the AmpliPHI battery is kind of the brains of the operation, or I shouldn't say it's not the brains, but it's kind of the crucial, hey, I'm controlling the game here as far as programming goes, and kind of overriding anything that it sees that it doesn't like to make sure that you stay within those kind of parameters. So it takes a lot of the guess and check work and the programming out of the system. It's really only applicable when connected to an inverter it is set up to communicate with. And really that's Solar right now. I've heard one is pretty much done at this point. I'm not sure where we're at as far as announcing that kind of stuff. So I leave it be, but I know we have some more on the horizon. So again, to go kind of into the products here, the standard Phi products have the internal analog BMS. So this could be, just a Phi 3.8, 48 or 24 volt, or a 1.4 kilowatt hour battery. The Phi battery line does not have a communications capabilities and do not require battery to battery connections for proper installation of functionality. So, I think something that is often brought to my attention is, well, hey, I just want the more advanced one. Why not? Well, there's a time and a place for both batteries. And frankly, the Phi product line is less expensive. So in certain situations, you really aren't going to be required to use that more advanced or a digital BMS with that comms-based battery. So, like a lead acid replacement, oftentimes I see it's not really necessary, and there's less cable runs now. It's more affordable. So sometimes that might make sense. And even though that the batteries do not have connections from battery to battery, they can actually be scaled to meet any energy or battery demand and do not have a maximum limit for parallel connections. Our COM-based batteries does have that limit. I believe it's in the 70 battery range right now. They just updated it recently, so apologies for not knowing off the top of head, but that is a big difference here with the standard battery. The BMSs are not connected, but scalability wise, you can still scale up as big as you want, and actually bigger than the AmpliPHI. So the AmpliPHI, as I mentioned, again, this is where our closed loop communication comes in. This is where that digital BMS battery management system is, that closed loop communication with the auto-populated set points, advanced integration with the Solar converters. So what does that mean? Again, auto-populated set points, higher level protection. And you can think of this really as kind of what Matt's talking kind of really brought together here is looking at, I don't want to say the shortfalls, but looking at what a battery management system's limits are as far as protecting from things like voltage and stuff like that. The digital BMS is a bit more responsive. It has the ability to kind of communicate things to the system that it doesn't like, as well as turn off components that it doesn't like. So in that sense, it has more available as far as what it can turn off and on, and what it can ensure doesn't change. It also leaves a lot for you. It takes away a lot of the user error abilities. If you're an installer, you program the Phi battery completely right. Maybe you've got a customer that doesn't know how to keep their hands too much off the system, and they mess with some set points that are out of the spec that you programmed. that is a situation that's happened or it might still happen. That set point might have been changed. Maybe they up the charge volt or charge current and it's too much now and they damage their battery. Well, the good news with the Phi battery, when it's hooked up to what it's communicating with, it has the ability to say, hey, you try to program a setting outside of my parameters. I'm not going to accept that. And it knows its limits and it will revert back to what it knows is the correct set point. It also does high level accurate readings like state of charge, voltage, charge, and discharge. So if you've got a customer that's really looking for that kind of granular, hey, I want to know exactly what my gas tank is and how much energy I have in a percentage form, this is a good battery for that. And the BMS can definitely communicate that. Flexible sizing to the inverter. So unlike the 2-to-1 ratio we see with the Phi, if we're hooked up to the solar, we can technically size our AmpliPHI smaller than the inverter size. I try not to overdo that. Like if you have one AmpliPHI battery on a solar, you're probably going to run into some capacitor issues where it's hard to get the inverter to turn on that first time. But let's say, you have 3 batteries on a 12 kilowatt hour solar, kilowatt solar. It's not a problem because the battery can actually dictate its own discharge, and it can even register when there's more or less batteries in the system to make sure that the inverter itself does not over discharge. So that 2-to-1 ratio just isn't as much of a factor. Again, scale factor, however, how many batteries you put in parallel, there is a bit of a limit. I think, Matt, if you know it off the top of your head, feel free to say something, but if not, I think it's like 70 something. And really, that's a lot.
75.
75. So we're talking quite a bit for the most part. All right, I'm gonna take control back here. There we go. So the last product I'm going to talk about is our high voltage. Matt talked about external battery management systems, stack controllers, and the way that function works. I won't harp on it too much, but that is what you're going to get when you look at our high voltage products. So the SimpliPhi high voltage product can be put into series stacks, 200 to 1,180 volts DC nominal. And then from there, we can actually stack out in parallel to build up on the energy storage. Each battery module is connected to the stack controller BMS in the switchgear. Cell interface may be either internal or external to the module case. Battery monitoring actually here is if there's a built-in battery monitoring system into the stack controller itself, where we actually have that ability to see modular level data at a very, very granular level, and even see things like faults and even get into the system and clear faults from remotely. So there's a little bit more to be done here as far as like that more advanced system or excuse me, not system monitoring, battery level monitoring, that really granular data that we might be looking for on these high voltage, larger scale systems. Second here, there it goes. So let's talk about choosing the right product. I kind of touched on it there a little bit regarding, why you might want to choose the Phi over the AmpliPHI, but let's dive in a little bit more. And how does the BMS play into that? All projects are different, and it's often important to understand each project can benefit from a specific battery and BMS combo. So, looking at like an off-grid and a lead acid replacement, I see a lot of those where just the Phi battery, again, it's a little less, it's cost effective. If you're using older equipment, so maybe it is a lead acid replacement, you're probably not going to be able to hook up communications either way. So why waste the money on the communications battery instead of just going with the standard Phi? And that's really something that we try to do here at SimpliPhi, is keep the less or the more affordable version without the comms for projects that don't require communication. So you're not paying for that function that you're not using. A grid tied system, maybe somebody's monitoring very heavily, as I just mentioned. That's a good use case for the AmpliPHI, where they want that really high level state of charge, voltage, things like that. They want to make sure it's really as accurate as possible and it's coming right from the battery. It's a great one. Advanced grid interaction. They can kind of fit into both categories as far as the battery goes. but the AmpliPHI does have a little bit more granularity as far as what it's reporting and what it's capable of when it's hooked up to a more advanced inverter. So that one's kind of a toss up, a nice little coin toss there as far as which one makes sense. CNI projects, again, stack controller, you probably want something a little bit bigger. I do see some CNI projects that are low voltage, might be a great use case to use the AmpliPHI, or maybe the Phi battery, because it has that scalability that it's just, there is no limit to how many you can scale. So that might make sense in a lot of these commercial projects that are sticking with that 48-volt module. Now, CNI on a high voltage, it's kind of it's obvious, it's an obvious throw there to the high voltage product, which is the stack controller, that external advanced battery management system. So you can kind of see here how it really is, a wide variety there of different products. And again, to kind of wrap this all up before I go into our Lead IQ program and wrap up with some Q&A here, we really do try to keep these product lines available. So, while we could just advance our Phi battery to the AmpliPHI and get rid of the analog BMS completely, the cost would go up. And also, again, you're paying for functions that you're not using. Even as our cost comes down, we prefer to have that Phi battery sit below it so that if you don't need it, or maybe you just prefer the kind of traditional programming, it's available and it's there. And with the high voltage stuff, again, we're trying to fit into all these different needs of our customers and our installers. That being said, if you are an installer of our products already, check out our installer elite installer qualification program. It makes a lot of sense. If you're installing our batteries already, you're going to have highlight project deployments and company through the SimpliPhi marketing team, included in our IQs newsletter. You'll end up on this where to buy map, which shows a lot of visibility into, hey, this person has gone through the program. While it's not a requirement to install our batteries, you are shown as the most trusted because you've gone through this program, as well as it's free marketing for people that are browsing our website. Maybe they're a homeowner, they're looking for a battery to get installed, and they see you on this map with your info and your company's info. So again, even if you've just done one installation, go ahead and sign up for this program. You can actually go to SimpliPhi IQ Installer Qualification Program and scroll down to see the application. It takes about 10 minutes, or just shoot me, Matt, or myself an email at training@simpliphipower.com. I believe that email is going to be at our very last slide, but again, that's training@simpliphipower.com, and we can shoot you over the links and get you going on that. All right, I only see one question right now, so I'm going to pop open the Q&A. If you have any questions, now is the time to put them into that Q&A. And we can see what's going on. Are the Modbus tables available to the public for the third-party devices? Good question. Typically not. We typically are only going to give out that kind of information if we're working with you on a certain project, or maybe you are another manufacturer that needs that to move forward. If you have a specific reason though, and you think it's valid, you can always reach out to our sales team, and they might put in some NDAs if they think it's necessary and get things moving if you do require that. All right. Well, it looks like we don't have any questions today. If you
actually have a question for you as well.
Oh, perfect.
I'm wondering if you have met any people, maybe off-gridders, for example, that prefer the Phi battery over AmpliPHI regardless of cost. I'm thinking about some other advantages, like just lacking an extra possible point of failure, or, as far as that scalability, I mean, it's rare, but we do see systems that are, 80 plus batteries on occasion.
Sure. I think so. That one is a big one right there. And then, again, like you said, it's kind of the tried and true. Well, I wouldn't say the AmpliPHI is harder to work with. It's more advanced. There are a little bit more bells and whistles to work with. The programming is a little easier because it does it all for you, but a lot of off-gridders just kind of want that just very kind of brawny kind of, I don't even know how to describe it, kind of just workhorse of a battery. And the Phi battery has been around for a really long time. And it's definitely something that I think it makes sense for a lot of off-gridders to use. And I do see people that prefer it. Looks like we have some other questions that have come in. What is the volume of sales, Phi versus AmpliPHI in percentage? I don't have that figured, not on the sales team. I would say the AmpliPHI is a newer battery launch, so it's still catching up a little bit to the Phi. But as you can imagine, comms are definitely becoming more and more popular, especially on the residential grid tied market. I'm going to go ahead and answer this one, then I'm going to probably ask you the next one, Matt. Can your batteries be used with the SMA Sunny Island inverters? Why don't you reach out to us direct? I know we are working so hard on that one. I think the sales team probably will have more information as far as what's been signed, or as far as, what's been approved and what SMA is approving. But I believe it might just be ready, so don't quote me on that. But please go ahead and just reach out to sales@simpliphipower.com. And anybody will grab it from you, and they should be able to help out if you have some projects. I'll shoot them a ping here and let them know somebody's going to send a message. Does the BMS could be installed in my host and server in different clients? I'm not sure I get that question. Matt, do you get what's going on there?
No, not totally sure.
Apologies, Douglas. I'm not sure I understand the wording there on that question. But if we can't get that answered on live, we'll be happy to look at it offline as well. So feel free to shoot us an email, training@simpliphipower.com, for a little bit more clarification. We can figure things out. All right. Well, that looks like we just wrapped up. I just want to say, we got a couple more here. All right. Is there an LCO device you would recommend for use with inverters that don't go that low? Low LBCO. Yeah, LVCO. You fixed it there. Matt, you want to talk about that one? I feel like that's your favorite territory there.
Yeah, so we'll have to talk with Parker about that one. He actually was the one who found that low battery cutout device that would work with inverters. However, I just would advise that, a workaround or adding an external device to a system is definitely, it's something you would do in a worst case scenario, right? So if I have my existing battery system and I realize, oh shoot, I forgot that I need an LBCO device, and then maybe I add it on. But if you're designing a brand new system, don't design a system with workarounds and a bunch of external devices. Try to design it so that everything in the system is working together. So we'll do our best to hunt down that device for you and send it over. For example, the Victron Battery Protect works really well for DC loads, but it doesn't work well with inverters.
So I do want to jump in here. I see you've added something on Schneider and Outback. Apparently can't protect the PHIs. Not true, actually. They can. The Outback can go up to 50.2, which is 80% depth of discharge. However, we have had some bugs where that doesn't happen. The Schneider can only go up to 48.0, which is still an acceptable low battery cutout voltage. So we absolutely work with the Schneider and the Outback inverters, and they can hit that protect on the low battery cutout. So if you're having any issues programming or anything, just let us know. We'll help guide you through that checklist there. This question typically has come up every training so far. How's the corporate acquisition going? So how's the acquisition going as far as Briggs and Stratton has acquired us? It's been amazing. We're really excited. Anything new coming down the pipe, I can't speak too much there, but some big things coming, I'm sure. And we're just really excited to be part of a larger company here that has the resources and same messaging and focus as we do. So we're really excited about that. And it can only be good things as far as growth and continuing to advance our products, our technology, and bring down cost always as much as possible. Okay, for the digital BMS, are they all on user interface? Can they also be programmed by pressing the buttons, or do you need its software in the PC to do it? Sometimes in the field, you might be without PC. I can take that one. So the BMS automatically puts in the set points that you want into the inverter or the charger. And you can have the ability to go into so let's say you're hooked up to a Solarc, you can go directly into the Solarc and manipulate those settings. If you try to put in a setting that's incorrect, so maybe it's too high or too low, and it's going to hurt the battery, it will auto fix that setting. It'll say, no, you went too high. You don't have that much available current to push into the battery, and it will fix that. So it'll always make sure to fix that. But like, let's say it was charging at a max charge of 50 amps DC, and you only wanted to charge 25. If you set that lower set point, it will accept that. And you can do that from the inverter charger.
Gives the service with your BMS for serving a more than one client. The BMS is internal to each battery, if that's what you're asking. So, the AmpliPHI BMS comes inside the AmpliPHI battery. Each one has one BMS. Hopefully that answers your question, Douglas. If not, definitely email us.
All right. BMS can assist to detect earlier if stratification starts to develop in some batteries in the bank. As far as battery health, I gotcha. It's still, it definitely has the ability to talk a lot more as far as like cell level monitoring and things like that. It's typically not super accessible just yet by the customer. This is more of an advanced function where the BMS is logging that data. If we needed to pull it, we always could, but you'd probably see that on a modular level as well, as far as any sort of damage like that going on. All right. Well, before we have any more questions come in, I think we're good to go here. I just want to give everybody a big thank you for joining. This is definitely a fun presentation for both of us. And Matt, I appreciate you letting me join in on your presentation here.
Thanks. Always a pleasure.
All right. Thank you, everybody.